The James Webb Telescope has just announced the clearest image of Proxima b in history, revealing astonishing details about this potentially habitable exoplanet. Join us as we embark on a journey through space to uncover the mysteries of Proxima b and discover whether it could be the next Earth. Let's take off. In the vast expanse of space, a mysterious planet exists in the habitable zone of its star Proxima Centauri. This planet is not just any ordinary rock. It's Earth's cousin, Proxima Centauri b, located a mere 4.2 light-years away from us. This planet is shrouded in mystery and wonder. Could it be another Earth with oceans and life teeming on its surface? But wait, there's more. Proxima Centauri b is not alone in its journey around the red dwarf star. It has a fellow traveler, the super-Earth Proxima Centauri c, and who knows what other secrets this star system holds. Perhaps there is another companion that we have yet to discover. The mysteries don't stop there. Proxima Centauri b receives just about the same amount of energy from its star as our Earth does from the Sun. Could this mean that there is water on its surface, perhaps even life? As we venture beyond our own solar system, we discover a whole new world of exoplanets, planets that orbit stars other than the Sun. With 200 sextillion stars in the universe, the possibilities of exoplanets are endless. Some exoplanets even roam free, untethered to any star, like rogue travelers in space. But among them all, Proxima Centauri b stands out as a truly remarkable and enigmatic planet. With a year that lasts just 112 Earth days and a distance from its star that is 20 times closer than Earth is to the Sun, it is likely that one side of the planet is always bathed in daylight, while the other side remains in perpetual darkness. Now let's talk about Proxima Centauri, the star that Proxima b orbits. Proxima Centauri is part of the Alpha Centauri triple star system. This system includes Rigil Kentaurus, also known as Centauri A, and Ptolemy, or Centauri b. Together, these stars create the nearest star system to our very own solar system. The two stars, Rigil Kentaurus and Ptolemy, form the binary known as Alpha Centauri A and B. These G and K-type stars appear as one star in the constellation of Centaurus and are the third brightest stars in our night sky, with a peak magnitude of -0.27. Proxima Centauri, also known as Alpha Centauri c, is a red dwarf or M star located 0.21 light-years away from the other two stars, approximately 13,000 times the distance between Earth and the Sun. It is technically the nearest star to us. In fact, Proxima Centauri translates to the nearest star of Centaurus A in Latin. It was discovered in 1915 by Scottish astronomer Robert Thorburn Ayton Innes. Despite being our nearest stellar neighbor, we can't see it with our bare eyes. It has an apparent magnitude of 11.13, which is far greater than the maximum human eye limit of 6.5. But don't let that fool you. Proxima Centauri is still a star worth marveling at. Red dwarf stars like Proxima Centauri are among the most efficient in terms of energy production. They may not generate a lot of energy, but the internal convection process at their core keeps them glowing for trillions of years. In fact, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still being debated. For one thing, it's a flare star, which means it has frequent and unpredictable fluctuations. As a low-mass star, the habitable zone would be closer to it than that of the Sun, projected to be between 0.023 and 0.054 Australian dollars. But it's not as habitable as it seems. It might seem like a promising planet, but don't let its appearance deceive you. Sure, it's the same distance from its star as we are from the Sun, but that's not the whole story. You see, Proxima b is bombarded by extreme ultraviolet radiation from its star, hundreds of times stronger than the radiation we get from our beloved Sunday. That's right, it's so intense that even the lightest molecules of hydrogen get destroyed, let alone nitrogen and oxygen. But that's not all. Just because a planet is at the right distance from its star doesn't mean it can support life. Proxima b might not have a suitable atmosphere, which is essential for regulating climate and supporting a water-friendly surface. Without it, living organisms will be vulnerable to dangerous space weather, making life nearly impossible. So, while Proxima b may look like Earth on the surface, it's far from being able to support life. People have doubts. While there are numerous factors that render it unlivable, the quest to uncover the truth about Proxima b continues, and some people still have hope. One instrument that has captured the attention of astronomers is the James Webb Telescope. After numerous delays, the telescope was finally launched in 2018 and will help us determine whether or not there is life on Proxima b. As with all things in science, things are never quite as straightforward as they seem. Many modifications were required to ensure that the James Webb Telescope produced accurate images. As Avi Loeb, a theoretical physicist at Harvard, explains, if a planet like Proxima b can absorb light from its star, it can also re-emit it as infrared light. The James Webb Telescope was specifically designed to observe infrared light. It can take photos of this light on the surface of the planet and look for patterns that could confirm whether the planet has water or an atmosphere. But what if the planet has an atmosphere that is not conducive to life? The presence of an atmosphere does not guarantee the presence of life, warns Ed Turner, an astrophysicist at Princeton University. Proxima b could be like Venus, with a thick atmosphere that is 90 times denser than that of Earth's and extreme heat that would make it impossible for life to exist. The quest to unravel the mysteries of Proxima b is not without its challenges. While the James Webb Telescope holds promise, there are other factors to consider. With costs mounting, astronomers are hard-pressed to find a way to observe planets like Proxima b. The risks are great, but the rewards are even greater. The chance to glimpse into the unknown, to uncover the secrets of a distant planet that holds the promise of life, is one that astronomers are willing to take. Traveling to Proxima b, let's say hypothetically the exoplanet was hospitable. Could we even go there? It's the closest exoplanet to us, which makes it so exciting because it's almost like looking in our cosmic backyard. What's even more interesting is that it's roughly the same size as Earth, and its location in the habitable zone means it could potentially have the conditions for life as we know it. Proxima's proximity also makes it a prime target for our search for life beyond Earth, and with it being just around the corner, well, relatively speaking, it's a great contender for interstellar missions. Imagine the possibility of exploring this Earth-like exoplanet. Though we can't travel there yet, it's definitely on the radar for future missions as technology makes it accessible. It's one of the most exciting projects in the field of space exploration. But getting there is no easy feat. It would take 75,000 years for a spacecraft like Voyager 2 to reach the Proxima Centauri system. However, a solution has been proposed: solar sails. These ultra-thin sails could be used to accelerate a spacecraft to the Alpha Centauri system, and Proxima b along with it. This technology uses solar pressure to keep the spacecraft on course, eliminating the issue of running out of fuel. And with expected speeds of 10 to 20% faster than the speed of light, the journey to the Alpha Centauri system could be reduced to just 20 years. The discovery of Proxima b has reignited humanity's fascination with space exploration. It has given us a newfound sense of hope that we are not alone in the universe. The James Webb Telescope is a marvel of modern technology that has the power to take us all the way back to the very beginning of the universe, 13.7 billion years ago. Here's how it works. The farther away an object is, the longer it takes for light to travel from it to us. This means that the James Webb Telescope can actually see objects in the universe that are farther away than any other telescope before it. Plus, it has the capacity to observe these objects in longer wavelengths of infrared light, which means we can see even more distant stars with greater clarity than before. And you know what's even cooler? This incredible technology has the power to shed light on the possibility of life on other planets like Proxima b. But as with anything this awesome, there are some limitations. For example, the presence of an atmosphere doesn't necessarily guarantee the presence of life. Proxima b could be like Venus, with a thick, hot atmosphere that's not suitable for life. And get this, The James Webb Telescope has the power to detect such illumination if it reaches a brightness of just 5% of the natural day side. Now, 5% might not